Hey guys, welcome back to KAYIE'S Creative Learning. I'm always happy to have you and I'm always appreciative of your presence. Today, we will be still looking at fractions, but we will be comparing fractions with different denominators. Now, for those of you who are joining for the first time, my name is KAYIE Harrison and I'm happy to have you. Remember, do not leave without tapping that subscribe icon and that notification bell, and also share it with your families and friends. So today, the topic is comparing fractions with different denominators. Again, a fraction is made up of two parts, a top number and a bottom number. The top number is called our numerator and the bottom number is called our denominator. The denominator tells us how many parts the whole is divided in, and the numerator tells us how many parts of the whole we are being considered. Now, because we are comparing, we have to talk about what that means as well. So to compare means we're looking to see, are these fractions equal? Is one greater or is one less? Now, when we compare, we use symbols. This is the easy one. It's equal. By now, we all should know that this symbol means the two fractions are equal. These two are the tricky ones. Now, remember, pretend that these are sharks, hungry sharks. Now, this is the mouth and this is the mouth. If a shark meets a fish, it's going to open its mouth to the bigger one. So this one means the greater number is on this side, the shark is opening its mouth to it. And this one means the greater number is on this side, the shark is opening its mouth to it. So always make sure your shark is opening its mouth to the bigger number and turning its back to the smaller one. Now let's move into it. So because the denominators are different today, it gets a little bit trickier, but I'm going to show you two different ways in which we can compare these and make it pretty easy. The good thing is you already have knowledge about equivalent fractions, and we're going to use the same concept that we used when we looked at equivalent fractions. So today we have 3/4 and we're comparing it to 1/2. So the first way I'm going to do this is by making the denominators the same. Once the denominators are the same, it becomes easy. So to make the denominators the same, we need to figure out what can we multiply by 2 to get 4, or what can we multiply by 4 to get 2, just like when we did equivalent fractions. So is there a number that you can multiply by 4 to get 2? Now, is there a number that you can multiply by 2 to get 4? Of course, that number is 2. So if I multiply this 2 by 2, it becomes 4. So I'm rewriting my fractions. So this denominator is now 4 because I multiplied by 2. If I multiply the denominator by 2, then I also need to multiply the numerator by 2. So first, I have to figure out what is it I need to multiply the denominator by to make it equal to this denominator. And whatever I do to the denominator here, I have to do it to the numerator to make it equal. So 2 times 1 is 2. So now I have a new fraction, which is equivalent to 1/2, which is now 2/4. And I'm going to bring down my 3/4 so we can compare them. So the denominators are the same. And remember, once your denominators are the same, all you need to do is look at those top numbers, the numerator. So this numerator is 3 and this one is 2. Which one is bigger? It is, of course, the 3. So my hungry shark or my greedy shark is going to open its mouth to 3/4. It simply means that 3/4 is greater than 1/2. Pretty easy. Let's look at number 2. That's only one way. I'm going to show you another way. But let's look at number 2 first. So this time we have 3/8 and then we have 5/16. Again, we're going to try to make the denominators the same. So ask yourself, is there a number you can multiply by 8 to get 16? Of course. If I multiply 8 by 2, it is going to become 16. So I'm rewriting my fraction or renaming my fraction. If I multiply the denominator by 2, of course, I need to do the same thing to the numerator. So 3 times 2, that's 6. Now that this is named 16ths, I can just bring down this 5/16. So my denominator is now 16. So you don't need to do anything to this part because it is already 16ths. We're just renaming this one with an equivalent fraction so that now it is also 16ths. Now that both fractions are 16ths, I can check to see which of the numerator is bigger or smaller. 6 is greater than 5. So it simply means 6/16 is greater than 5/16, or 3/8 is greater than 5/16. So you might be wondering, how is it I'm going to use this instead of this? Remember, we looked at equivalent fractions. They are equal, they just have different names. So 3/8 is equal to 6/16. They're the same. They only have different names. So we can rename it and use it to help us. Now, let's look at the second way to do this. All right. So another easy way we can do this is using the method that we use in a previous lesson called the butterfly method. I bet you remember that butterfly method. All right. So I am going to first rewrite, not rename this time, just rewrite my fraction. So 3/4 and 1/2, the same fractions. Now I am going to use the butterfly method to figure out which one is greater and which one is less. So remember, when we do the butterfly methods, we're going across. So this denominator times this numerator, and this numerator times this denominator. So it's like cross multiplying, but we can call it the butterfly method just the same. So we're now multiplying 4 times 1, and that gives us 4. Then we multiply 3 times 2, and that gives us 6. Now the bigger product names the bigger fraction. So because we got 6 here, it means that 3/4 is greater than 1/2. So there you go. So simply do the butterfly method, multiply across, and the one with the bigger product is the greater fraction. Let's try it over here. So again, I'm rewriting my fractions, and I am going to be doing the butterfly method. So it is 5 and the 8 that goes together, and 3 and the 16 that go together. These are bigger numbers. Now 8 times 5. Remember, if you don't know, boys and girls, you can skip count. So 5, 10, 15, 20, 25, 30, 35, 40. 1, 2, 3, 4, 5, 6, 7, 8. So that is 5, 8 times, meaning 5 times 8. That is 40. Now we have 16 times 3. I'm sure, boys and girls, we don't know how to work that out mentally. So we can write our 16 and multiply by 3. I taught you how to do that. So 3 times 6, that's 18. And then 3 times 1 is 3, plus 1 more is 4. So 16 times 3 is 48. Again, 3/8 is bigger because it has the bigger product. So 3/8 is greater than 5/16. So boys and girls, don't look at the 16 and say that it is bigger. No, you have to make sure that you're cross multiplying or you're renaming one of your fractions. We're going to look at 2 more examples and then that's going to be it for today. All right, so this one, both numerators are 1, but the denominators are the same. This is something you can remember. So remember, if this denominator is 7, it means that your cake is divided into 7 equal parts. This is 6, it means that your cake is divided into 6 equal parts. So if my cake is divided into 6 parts and your cake is divided into 7 parts, whose cake has the smaller slices? It's yours, because yours is cut into more parts. So your cake would have smaller slices. So when the numerator is 1, you're looking at the fraction with the smaller denominator. When both numerators are 1, you're looking at the fraction with the smaller denominator. So without doing anything, we know that 1/6 is greater than 1/7, because if it's 6, the cake is divided into 6 parts, and 7, the cake is divided into 7 parts. So you're getting smaller slices, and we only both get 1 slice. So my slice, which is 6, would be smaller than your slice, which is 7. So you don't need to do any cross multiplying. You don't need to find and make the denominators the same. Just look at your denominators and see which one is bigger, which one is smaller, and think about a cake or a pizza and see which one would have smaller or bigger slices. Let's look at another one. This is 1/5 and this is 1/9. So 1/5 means your cake is divided into 5 parts. 1/9 means your cake is divided into 9 parts. Your slices are going to be smaller because you cut it up into more parts. So it simply means if I get 1/5, my slice will be bigger than your 1/9. So remember that. Denominators are different. Numerators are both 1. Think of the denominators as a cake or a pizza, and you cut it up into slices. Which one would have the most slices? Anyone have the most slices? Those slices are going to be smaller. So the one with the less slice, that's your bigger fraction. And if you don't believe me and you want to cross multiply, 5 times 1 is 5 and 9 times 1 is 9. 1/5 is bigger. Do the same here. 6 times 1 is 6. 7 times 1 is 7. 1/6 is bigger. So easy. Let's move on to another tricky one. So this time I have 5/6 and 3/4. Before, we were asking ourselves, is there anything I can multiply by 6 to get 4? No. Is there anything I can multiply by 4 to get 6? No. So if I need to rename my fractions, I'm going to have to rename both of them, because this cannot be multiplied to get this, neither can this be multiplied to get this. So I have to rename both fractions. Step 1, we have to find the LCM. Who remembers when we looked at that? LCM means the least or the lowest common multiple. Some people will say LCD, least common denominator. So remember, to find a multiple, you skip count. So we're going to skip count by 6 and we're going to skip count by 4 to see if we can find a number that is both a multiple of 6 and 4. So I like to go up to 5, skip count 5 times, and then go to the other number and see if I have any. So let's go. So 6, and 6 more would be 12, 6 more would be 18, 6 more would be 24, and 6 more would be 30. When I skip count by 4, if I don't find a denominator that is the same, I have to go a little further. Let us see. So I'm starting at 4. 4 plus 4 more, that's 8. 8 plus 4 more, that's 12. Do I need to go any further? No, because I found out that 12 is a multiple of 6, and it is also a multiple of 4. It simply means I don't need to go any further. But pay attention to this. Now, all I need to say to myself, how many times did I skip count by 6 to get to 12? 2 times. So it means that if I multiply 6 by 2, my new denominator is 12. Anything I do to the denominator, I have to do it to the numerator. So I'm going to multiply my 5 by 2. So 5 times 2 is 10. So 5/6 is renamed to 10/12. They are the same value, just different names. My next step is to ask myself, how many times did I skip count to get to 12 when I skip counted by 4? 1, 2, 3 times. It simply means I am going to multiply the 4 by 3. So 4 times 3, that is 12, my new denominator. And anything I do to the denominator, I need to do it to the numerator. So 3 times 3 is 9. Now I have 2 fractions that are named 12s. This one is equivalent to this one, and this one is equivalent to this one. So I can use them to determine which is greater or which is less. My numerator here is 10. My numerator here is 9. I have no doubt that you realize that 10/12 is the bigger one, which simply means 5/6 is greater than 3/4, or 3/4 is less than 5/6. All right, so if you did not want to rename them like I did over here, you could simply do the butterfly method too. So once you don't want to rename, go butterfly. So let's do the butterfly. So 6 times 3, that's 18, and 5 times 4, that's 20. So it's obvious the product 20 is greater. So 5/6 is definitely greater than 3/4. So guys, if you don't want to go through this process, simply do the butterfly method. But it's good to know every single step. That's it for today. We're comparing fractions with different denominator is concerned. Hit me up if you need more clarification, and you know I'll be here to help. Remember to like this video, leave me a comment, share it. Someone else might need it, so share it, guys. And if you have not subscribed yet, if you have not turned on your notification bell, do so. Thank you. See you soon. Bye.